I'm going through it later and figure out like what we're doing. Okay, yes, so you guys need stuff. Tickets. Right. That's right.
Oh wait, I can't go Saturday if you drive me. I'm going
Oh my gosh, Maggie Smith. My 4x15.
Because I know they tried
And Mary's going to, I suppose.
Mary's leaving Thursday.
There's
She's
4x18.
going with something else and then I'm going to be for me. What way is the 4x8? Saturday?
I don't know. It's on Friday we can do it. Oh, no.
Mary's on
Mary's
here.
All right.
Am I running to all of them besides that?
Yeah. So we'll see.
Tuesday, Friday, Saturday meet all the same week. Which is a lot of time.
That's just a lot.
Did we turn it on?
Oh my gosh.
Why are some meets shorter than others if they're all the same event?
Just depends on how many teams are there. Mine was like 50 teams.
Oh, so many more heats.
Yeah. Yeah, the tidbits are on the shelf actually in the middle if you want to get the tidbits.
Is that?
But yeah, it's from Friday, yeah. 5, 4, 3, 2. All right. Hey kids, it's sample test day.
Whoa.
All right. Now, can somebody tell us in number 1 what the key word is in the very first problem, inflection? So inflection tells you to do what? Double derivative. By the way, you know the easy way to do 5 times 18? 10. Remember that trick we did in class? Yeah. 10 times means add a 0, that would be 180. Cut it in half, that would be 90.
What?
We will do a lot of multiplying big numbers by 5, a lot bigger than 18. So remember that trick. Add 0, cut it in half.
Sample test.
Yeah, the sample test is back there, and the tidbits 11-5. Need that too. Okay, now 445.
180.
180, good.
Really?
15's gone.
I'm
Okay,
not going at all.
here we go again. 5 times 12 is 60. X to the 4th. Because you can just add a 0 and cut it in half, right? 4 times 9 is 36. Add a 0. And 3 times 18 is 54, add a 0, so 540. Okay, now your multiplication tables, kids. All right. Also, trust that this is going to be handcrafted somehow. 60. Oh my gosh, look at all these insane numbers. Don't worry, they'll all come out. Take out a 60 and an x squared, and look what happens. 6 times 6 is 36. 6 times 9 is 54, and look at it all work out there for us. Yes, indeed. Okay. And if you wish, this is not mandatory, but it's kind of nice. Isn't this just x minus 3 quantity squared? It's a good idea to go ahead and do that. Okay, very nice. All right, so you take 2 derivatives, factors well, and of course the first thing you do is set it equal to 0 to figure out your potential inflection points, right? And on this one, we have 0, and we have positive 3. Counted twice, but it really only counts once. Okay? All right, and it says, how many inflection points are there? Oh, 2.
One could be.
Or could there be a false reading? Well, we better test it. Okay? Maybe we just got a shoe on the fish finder. So you got to check it just in case. All right? If you plug in, let's say like negative 100, 1, 100, okay? If you put anything into 60x squared, you know what happens? Positive. What happens if you put anything into x minus 3 quantity squared? Oh, everything is plus plus. That means it's a plus, and a plus. They were both fake. How about that? How many inflection points are there? None.
Or 0.
Or is 0 be okay? Okay. All right, don't have it. Okay. So we check up on the test. I'll tell you right now, there will be at least 1 false one on the test. At least, if not 2 or 3. When you get here, don't stop, double check, and you're done. Okay? Just can't double check? Yes, and you have to have a sign. All right? Okay, number 2. Oh my gosh, Mr. Wade, that's a terrible equation. 56? Okay, oh yes. You may think it looks terrible now, but wait until you get to the second derivative. Okay? We are looking for inflection. So once again, take 2 derivatives. All right, bring the 8 down. What if 8 goes into 56 even?
Yeah.
Let's just leave it.
Okay, actually, you could. Because it would cancel anyway, right? Okay, 1, 7. Oh, thanks, Mr. Ray. 6s cancel out. Ah, yes, very nice. Beautiful. Getting better. Oh, I see. 7, 7. X to the 6th, 25x to the 4th. Now we're talking. Okay, all right, get to the second derivative, and of course you would take that and set it equal to 0 and try to factor something out, right? Make something. Okay, let's see what can come out of this one. X, actually it's the 4th, right? Oh, yes, indeed. Mr. Wade was busily at work on this one, wasn't he? Okay, making that just right for all the kids. Okay, and so it's going to be x equals 0 and plus or minus 4. Okay, you guys are all inflection points. Oh, not necessarily. You might already be able to just glance at this and tell me which root's going to mess up, actually. Because don't the roots come from the corresponding parentheses? I see a root that came from a group that's not going to change. I got a hunch. Okay. That 0 is not going to work out. Because it came from a 4th. If it was a 3rd power, it would be a sign changer, but not the even powers. Okay, so you do this and you do that, and you pick some family points. No matter what you pick, though, x to the 4th is always what? Positive. The first one is always 4. You can just sweep it under the rug, right? It's not even put it. But the other group, x squared minus 25. If you took like negative 100 and squared it, what would happen? Gigantic, right? Minus 25. If you took like, let's say, negative 1 and squared it. Ooh, that's right. That's a smaller minus a bigger is a negative. You put in positive 1, same outcome, still negative. Oh, we didn't transgress the root. Then you transgress the other root, what do you know? It changes. How about that? Look at how it does. Okay. So you end up getting plus, minus, plus. That even power was not a sign changer after all. Therefore, you only have 2 inflection points. Remember, it has to be a sign changer to be an inflection point. Otherwise, inflection didn't change the concatenary, so it's not an inflection at all. Got to change your concave up to concave down, or vice versa. So the answer would only be what?
Plus or minus 5.
Plus or minus 5, and that is it. Leave off the 0. Okay? So the major theme there in number 1 and number 2 would be double check all of your potential inflection points. You never know. There could be some sneaky business going on there. All right? Nobody likes sneaky business. Okay? All right, inflection points for this one. Okay, so let's take 2 derivatives again. What do we have here? We have both variables, both being multiplied together, got to be product rule. It's the only way to do it, right? All right, so the first derivative would be di. What's di? 3. That's 3. Plus high. What's d ho?
Either the negative x.
Either negative x, and the chain rule is a negative one, so it actually changes the sign, doesn't it, right? We left off the natural log of e because it doesn't really matter here, right? Okay? All right. Let's not take another derivative yet. That would be horrendous. Make it look nice. Factor something out, such as 3 and negative x. Okay? All right. Well, nothing's left here, so I'll just put 0. I still see some people doing that in class after all this time. Can you believe it? In an honors class. This distributed to 0 gets back to itself. Shocking. Right? So not you, not any of you kids, because you guys are all sharp, right? Could you just cut that out?
I don't know.
Okay. Now, look for the Easter eggs. Easter's coming up soon, kids, isn't it? Right?
I sometimes feel like some pictures are between us.
Some of you have Easter eggs in your progress report right now, right? Now, X times -1 is a minus x. Okay, a little subtle. All right, so now let's go to the second one. Okay, the next derivative would be, once again, product rule, multiplication, both have variables. Let's do another product. Okay, ho d high. The derivative of 3e to the negative x is good. Itself times the chain rule of -1, right? That's the whole thing with the e's. If it's e to a negative, they just keep going back and forth and changing sign. Okay, plus high d ho would be -1. And this time you factor. I think I take the negative with it as well. Yeah, it's not mandatory, but they both have negatives, obviously this time. So let's take out a negative and a 3 and an e to the negative x. Take out as much as you can. Okay, negatives gone. 3's gone. E to the negative x gone. Okay. 1 minus x is left over from the first group, and nothing is left over from the second group, so I'll just put a big old plus 0 right here. Plus 1. Okay? And that gives you a grand total of 2 minus x. Okay. So basically this is just a practice on the product rule here in factoring. And then when you get down to here, we have to try to figure out the neutrals. And it's going to be 2 for sure.
And that can be 0.
-3 can't be 0, can it? What about e? E to any power, even a negative power, is always what? Always positive. It's always above, isn't it? Right? So there's no way that can equal 0. Okay? So your only potential critical number here would be 2, and that's it. So the derivative test will be very easy for this one. One number, 2 sample points, you're done. 0, 100. Okay? And guess what? When you plug anything into -3, the outcome is -3. So that one's always negative, which is important. Don't change the sign. E to the negative x is always what?
Positive.
No matter what. Always positive. Okay? And the only thing that changes is in this entire expression right here is the 2 minus x. 2 minus 0 is positive, 2 minus 100 is negative. Okay? Everything else is quite stationary, just stays the same sign. So you end up getting a minus and a plus. Well, that's a sign changer, isn't it? And we're looking for inflection, so we'll take that 2 and we will plug it right back into original function. Do you notice the difference between number 2 and number 3, actually?
Point.
Okay, number 3 is a point. Number 2 is just the x. So make sure if you see point or coordinate on the test, don't forget to go back and get your y coordinate, right? It's easy to do, you just have to remember it.
Number 2 says x coordinate.
Okay, yeah, just the x coordinate. Oh, okay, yeah. So if it says x coordinate, it just be the x, of course. Okay? If it said find the coordinate in general, that is a full point. All right? Okay? All right, so make sure you take just a couple of seconds out of your busy schedule. Take 2 and plug it back in. And you're going to get 6. Eat it.
It's for tomorrow morning. I'll just go ahead. Go ahead.
That's for a valid purpose.
Yeah, I'll tell you later.
So never tell me what drawer that was.
Top secret.
All right, okay. 2, 6 e to the -2. There's your coordinate right there. Remember that e to a negative is the only negative power you're allowed to leave it now. So that's fine. Okay. Actually, I kind of prefer this a little bit better. I just like the look of it.